One feature of GREET has undergone some significant remodeling for the 2015 version, and that is the vehicle editor. In GREET 2014, the vehicle editor was limited in detail. Users could modify MPG, individual emissions, and upstream fuels, but little else. In GREET 2015, the vehicle editor is organized much like the stationary process editor and provides much more flexibility than in the previous version. Another improvement is the addition of helpful descriptions of features that pop up when the cursor moves over them. In this video, I'll open the vehicle editor to modify an existing vehicle and show how the editor is organized. Then I'll show the features in each of the 3 panels of the editor, and I'll finish with an example where I add a new vehicle. To add or modify a vehicle, we'll first go to the Data Editors pane and click Vehicles in the pane menu, just the same as in GREET 2014. I'll choose to modify a vehicle and select the dedicated ethanol car. The editor opens and we see 3 panels. In the center is the Vehicle Operational Modes panel, where vehicle modes of operation can be added and energy sources and tailpipe emissions can be modified. At the right is the Vehicle Attributes panel, where we can add more detailed information about the life cycle of the vehicle. And at the left is a familiar menu where items are selected to be dragged into the other 2 panels. You might notice that as I move the cursor over some features, a description or instruction is displayed. Another nice new addition is pop-up warnings that indicate when you've attempted an action that isn't allowed. In the Operational Modes and Attributes panel, you'll notice charting icons next to some fields. Clicking on an icon initiates a window where you can edit the time series for the data of that feature using a graph editor. In order to modify the time series values, you can either drag and drop the data points on the chart, or right-click on the value box and select Edit Values per Simulation Year. Now we'll look into each of the 3 panels, starting at the left of the screen. The first of 4 buttons in the lower left is for operational modes and vehicle power plants. If I drag a mode into the center panel, it becomes the main editing block there. There are 3 operational modes: regular, charge depleting, and charge sustaining. The regular mode is used for vehicles that have only one single operational mode, which covers most conventional vehicles, while the charge depleting and charge sustaining, or CD and CS modes, are used for vehicles with electric batteries, such as plug-in hybrids, which may have 2 or more operational modes. Within each mode, we need to drag in at least one vehicle power plant or powertrain, and there are 2 possible plants or powertrains: internal combustion engine or electric motor. I'll just say a few words about how the vehicle editor is constructed with modes and power plants. Modes determine the energy management strategy of the vehicle. For instance, whether the vehicle is running only on an internal combustion engine, or an engine and electric motor at the same time, or perhaps a battery and electric motor. After modes are determined, power plants are used as the technologies that convert energy into some form of kinetic energy or torque. Within an operational mode, 1 or more power plants can be active at the same time. Now, if I click on the button for energy sources, the menu displays the potential energy sources that can be dragged into a vehicle power plant. The menu is categorized into frequently used sources, liquid sources, gaseous sources, and solid or other sources. Clicking on emissions displays emissions that can be dragged into a vehicle power plant or into non-exhaust emissions in the right-hand panel, and there will be more on that in a bit. And last, clicking on materials displays vehicle components that can be dragged to the right panel to account for upstream impacts of those components of the vehicle over the vehicle's lifetime. By default, GREET includes lifetime tires and oil changes, as well as energy required for recycling, paint for the vehicle, and other similar materials. Moving to the center panel, we see a regular operational mode for the E85 vehicle and an internal combustion engine for the vehicle power plant. A vehicle can have multiple modes and multiple plants. A mode can be named anything, but for preloaded vehicles, remember that there are 3 operational modes: regular, CD, and CS. Here the mode is regular, and the vehicle miles traveled, or VMT share, is 100%. If I were viewing a vehicle with an electric motor, I could click Calculate, and the model would calculate VMT share for the CD and CS modes using a predefined formula that uses the electric range to find the mode shares. The vehicle power plant is named Internal Combustion Engine. Here too, you can name the plant anything, but the preloaded vehicles run on either an internal combustion engine or an electric motor. Below the plant name, there's something called Base Plant. You can click Base Plant to open a menu of baseline vehicles, which you can choose in order to compare to your new vehicle in the available charts. I can click to expand the energy sources and tailpipe emissions. Under Energy Sources, there are fields showing the rate of fuel consumption and charging or refueling efficiency. And there's a drop-down menu to select the upstream pathway for the energy source. Under Tailpipe Emissions, there's a list of emissions with their rate of release from the tailpipe, and additional emissions can be dragged into this area from the items list at the left. Note that CO2 and SOx will be auto-calculated based on a mass carbon balance in the fuel used, unless a user drags in a CO2 or SOx emission, in which case the user-entered value will be used instead of the auto-calculation. One more note about the Operational Modes panel. There are star icons next to the Mode Name field and Power Plant Name field. If you apply your changes to the vehicle, then click the star icon. That mode or power plant, along with its specifications, will be stored in a Favorites section of the items list. That way, if you're building a number of iterations of the same vehicle with slight alterations, you can drop in the base vehicle quickly without having to recreate it from scratch. Moving to the Vehicle Attributes panel, there are a number of fields toward the top: vehicle name, lifetime vehicle miles traveled, payload hauled by the vehicle, number of passengers for a trip so you can calculate results per passenger mile, then electric range if the vehicle has an electric motor, and finally urban share. Note that the electric range is only used to estimate the CD and CS mode shares when the user chooses the Calculate option. Otherwise, it doesn't factor in. In the bottom half of the panel, there are some tabs. The first is for the vehicle's construction. Here you can drag in materials to account for more detailed life cycle impacts from the vehicle. Just click on the appropriate sub-tab, and you can drag in a battery, engine oil, windshield fluid, etc., and fill in the relevant information. The second tab is for non-exhaust emissions, and the third tab is for any notes you may want to enter about the vehicle. Okay, in this last section of the video, I'll create a new example vehicle. I'll click on Vehicles in the menu and select Add Vehicle, and fill out some of the vehicle attributes at the right. Naming the vehicle is required, so I'll fill in Gasoline Car X, since the name Gasoline Car is already in use. I'll say it'll run for 160,000 miles, and I'll estimate that the vehicle will carry 500 kilograms with 5 passengers. So the well-to-wheel results can be reported in terms of unit per ton mile or unit per passenger mile. I'll specify the urban share, also required, as 69%, and I'll type a note indicating that this is a test vehicle. Next, I'll move to the Vehicle Operational Mode panel. Remember that typically modes are named regular, CD, or CS, though you can type whatever you like. Because I won't have any hybrid or electric capabilities, I'll type regular in the first field. Then I'll specify the VMT share as 100%. I'll drag in a power plant and call it internal combustion engine. I'll need to name at least one energy source, so I'll drag in reformulated gasoline E10. And I'll say the MPG is 27 miles per gallon. I'll leave refueling efficiency at 100%, and the fuel pathway is already selected for me. Now I'll drag in the emissions, VOCs, CO, NOx, PM10, PM2.5, CH4 or methane, and N2O. And I'll plug in some values. The operational mode is filled out, so I'll jump back over to fill out more attributes, starting in the Vehicle Construction tab. I'll click on Battery and drag over a lead-acid battery from the Materials menu. I'll say it weighs 30 pounds and that it will be replaced twice over the lifetime of the vehicle. I'll click on Fluids and drag over Engine Oil. I'll say it comes in 1 pound units with 8.5 units added at a time. It will be replaced 39 times over the lifetime of the vehicle. And the pathway source is engine oil fabrication. Finally, I'll add some non-exhaust emissions, along with some values. And then all that's left is to click Add as New. To view results for your new vehicle, go to the WTW pane and click to select your vehicle from the menu. On display is a large table for energy consumption and emissions with breakdowns of each, showing contributions from the different life cycle phases of the pathway. Options at the top allow you to select the units you like. If you click in the blank box at the top left of the table, it will highlight every cell, and then you can right-click in the box to copy all values if you want to move them over to an Excel spreadsheet. That's all I'll demonstrate for the vehicle editor. I will say, though, that while I focused on road vehicles here, the editor also supports the creation of other transport modes. You can create a plane with modes such as takeoff, cruising, and landing, or you could create an ocean liner with modes such as hoteling, cruising, and reduced speed zones. The editor was intended to support as many modes and power plants that you might need to perform a complete analysis. Stay tuned for more videos, and thanks for watching.